Welcome to episode 43 of this very impromptu stream tonight in this series where I'm programming an NES game live from scratch on Twitch. Let's get started. This is not a usual Thursday stream, but I've got some things going on, so I figured better to get a stream in today than to not stream, especially because I want to get these changes in for the map stuff that we talked about on Monday, so let's do that. So first and foremost, what I want to do is I want to change the asset tool to write out the map data a little bit differently. So what we were doing before was we were making the first full screen, what we wrote to the file, and then the rest of the content followed backwards line by line. Instead, what I want to do is I want to, after we write out our palettes, I want to just write the entire map. There's buffer information or attribute information, that will be missing, but that's okay. So let's get the main map written out first. So that should be easy. We just write our whole map buffer, and it's there you go. That writes out all the map data. Now this doesn't do a lot of the stuff that we talked about here. Last time what we talked about was that we wanted to be able to make it so that the map meta tiles were normalized for that particular map. So that we could look up the attributes more quickly, and specifically which palettes they used more quickly. But let's get the map loaded first, and then we will sort of work our way into that part. So shooter is there. Right, so we have to change some of this stuff around a little bit. Well, let's build our map first. So the only thing that should have changed is level 1 bin. And I'm going to try and keep this relatively quick. So I apologize in advance if I am kind of rushing through things, but I want to kind of do this pretty quickly and get this working, and then for next week we will have a working map with the attributes properly set up, and then we can kind of go from there. So let's see. Take the x and divide by 4. Well, so what we need to do is, so that's the palette, that's the row count, and then let's see. Sprite mem is being used for the meta tile values. What we need to do is we need to change sprite mem to reference the position that we want to start in the map. And the way we need to do that is we need to say whatever the row count is minus 7. Let's see. So we actually skip this here. Oh no, we have that max rows. So, and then we take that value and multiply it by 8 because it's 8 meta tiles across. So let's just do this here, right? So we say load a max rows, set carry, subtract carry, 7, and then we want to multiply by 8. So that is arithmetic shift left 3 times. All right, so now we've got that, and then what we want to do is we want to have that value I'm wondering if that's going to cause a problem with an overflow. So if we said it's 100 rows, yeah, it is going to cause a problem. Minus, is it 100 rows? It is 100 rows, right? Yeah, it's 100 rows, which is 800, which doesn't fit, which means that we're going to shift off. So what we need to actually do, instead of what we're doing here, let's see, so I'm pretty sure original bit 7 is into the carry, so what we would do is and then we want to rotate left, right? Shift all bits left 1 position, the carry bit shifted in bit 0, and 7 is carry. So let's see. So we want to store that in temp, and then let me think about that. Sprite mem. What would sprite mem actually be referencing? Sprite mem is referencing the position in the ROM where we've got the. Well, you know what? Let's not worry about that because we don't need to deal with that yet. We just need to deal with this being correct first. So, and then we'll add that to the value of sprite mem. So we're going to do the 1 shift, and then we're going to, well, we've got to clear the carry and then shift left, and then so we're storing that, and then we're going to load a temp2 needs to be 0 because we're going to use that for the upper 8 bits of this 16-bit value. So we're going to store temp A into temp, and then we're going to load A with temp2, and then we're going to rotate left, which means it's going to pick up the carry bit potentially, and then we need to store that back into temp2. And then we don't have to do the clear. Actually, maybe we don't even have to do that. So let's see. So if we have our max rows minus 7. Right, whatever that is, then we're going to shift it left. arithmetic shift left is going to change whatever carry was into bits from whatever the value was in bit 7. So if we had some value that was like that, it gets shifted left. This is the new end of it. This goes into the carry, and then we have temp 2 where we're going to push this over, and then this gets put over there because we're doing the rotate. But then we're doing a shift here again where it overwrites whatever the value is, so that's okay. We don't have to do any clearing there, I don't think. And then we're done doing that. I think that'll work. And then what we need to do is we need to load a sprite mem, clear carry, add carry, temp, branch not carry, branch carry clear to skip sprite inc. We're just going to reuse the label name, and that's going to go away. And then this is going to increment sprite mem +1, and then we're going to store. We need to do that here. Store a sprite mem, and then we're going to load a temp 2. Clear carry, add carry, sprite mem +1, store a into sprite mem +1, and that gives us our offset into the map, I think. 16 screen, do a 16-bit shift using carry to move most significant bit over to temp 2, and then add ROM address to temp and temp 2 in order to seek into map accordingly. And this goes away. This is supposed to be over here. And then let me see, do we? So last week we had changed the row mem stuff. Yeah, where this was offsetting differently than what it's doing today, or what it's going to need to do today after all of this. So let's get that. Well, let's make sure this math is working correctly here first. So where's the shooter? There it is. Let's go into the debugger and then load level. Looking at the source, right? Switch to source view. Yeah. All right. So here is our map position calculation. So let's make sure this is working correctly. All right. So temp 2 is now 0. Load max rows into A, which is 64. We're going to set the carry and subtract 7. And then what is this doing? Okay. And then, oh, that's weird. Why did it do that? Maybe it doesn't like the repeat in the debugger. Let me that just so it doesn't confuse anything. We need to do this 3 times. Yeah, no, Windows, I don't want you to do this right now. I don't know why. Just pick a time. Yeah, thanks. Here, do it at 11 p.m. I don't know why Microsoft thinks that this is better than what they had before. It's great that it totally interrupted what I was doing to tell me that it was going to interrupt what I was going to do. For no other reason than because reasons. I don't know. So 248. Okay, let's make sure. Let's see if this is going to work right now. All right, so we have our value here. So we're going to do a shift and carry is clear. So we're going to store that in temp, and then load temp 2 and do a rotate, which does nothing because we didn't shift a bit off. And we're going to store that, and then we're going to oh, that's the problem. Then you gotta load a temp again. Store it, then load temp again, and then we're going to do another shift, and then this time carry is actually set, so we store 74, we load temp 2, we're going to rotate to the left so it shifts that bit on. We store temp 2, which is now the value 1. We're going to load back this, we're going to do another shift, carry is 0, store it, temp 2 gets rotated so that it gets the value of 2. Restore that. So what we're looking at is 2E8, which, let's see what that actually equals. 2E8 is 744, and so it was 100 minus 8 times 8. Oops. 100 minus 8 times 8. 100 minus 8 times 8. 736. 100 minus 8 times 8, 736, 744 minus 8, so why is it off by 8? Temp 8C, and that's temp 2, 2E8, and just 2E8, 744. Did I not use the right value? What did I do? Max rows, ASL, store. That's weird. Max row is 64, right? That's 64 in hex. When you shift it, left shift 1, you get C8. Oh, well, it's 64, right? Minus 8, so you get 5C. Oh, not. Oh yeah, that's right. It's okay. Sorry, I forgot. It's 7 rows, not 8 rows. 100 minus 7 times 8 is C8. Except I'm doing it in hex. 100 minus 7 times 8 is 2C. $744. Yes. Okay. I don't know why I'm having problems with calculator today. All right, so final result is E8 to E8, which I think I said was 744, right? 744 to E8, yep, that's right. And then we're going to load sprite mem here. So load sprite mem, it's the value is D3. So we're going to add temp to that, and it carried. So we have BB, so we're going to store that, and then we're going to increment sprite mem. So it's got E9, right? Okay, and then we're going to load temp2, which is the value of 2, and we're going to store a clear carry, and we're going to add, and we're going to get E9 EBBB. And if we go to the memory viewer, we can go to EBBB. That looks like it could be right. Looks like it's, you know, a fairly reasonable location in memory for what it is. All right, so now we actually have to load the name table. And the other thing that it's going to want to do is it's going to want to load the attributes, which comes after, let's see, load Y. So we don't need to do this. 23C0 branch on equal load. So let's, this should be a bit, and then this whole thing can get commented out right now. I just want to see if it loads the first screen properly. Probably won't. That's okay. All right, well, we got some of the it's interesting. It's actually not too far off. Look at the map here. The beginning. Yeah, it's actually not that far off. It's pretty close. So let's take a look at this. Let's see what it's not doing right. So it's probably the sprite mem position that's wrong. Because it's, let's see, it's not, it's not taking into account the bytes for, well, is that right? Is sprite mem getting adjusted to take into account this other metadata? No. That's the sprite palette loop. Sorry, the palette loop. So once we have that, then what we need to do is we actually need to increment the value of sprite mem by 16, 17. So right, because we need to skip the first byte, which is the row count, and then we need to skip 16 bytes of palette info, and then, yeah, because sprite mem was originally just referencing the beginning of the map. All right, so more manipulation of sprite mem, same way as we were doing before. So load A, clear carry, add carry sprite mem, branch not equal, branch carry clear. Let's see what we got here. I mean, it's getting some of the right values, but it's still not quite 100% right. Let's do this. Let's make sure that the level buffer, or the level 1 file is right before I spend a bunch of time debugging this and then find out that I didn't even load the right level file. So we've got this, and then we've got 1, 2, 3, 4, right? And then if we were doing this properly, then we'd say 4, 5, 6, 7, 8. It'd be 56 bytes, right? It looks like this is the try to visually align this so it's a little bit easier to see what's going on here. So we should see three different numbers here for the beginning. Yep, that is the beginning. So let's see, what is the offset there? 749. So let's see if that's the offset that we're getting. When we're all done with all of this. Well, we weren't. We were getting 744, right? We were saying that it was 100 minus 7 times 8. 100 minus 7 times 8. What? 744. And then that's only 5 bytes. Why is that? What's up with the palette? I thought it was storing 4 separate. Write the 4 bytes of the meta tile palettes to be loaded. Oh, it's only. It's only 4. Okay. Right, I forgot that it's only 4 bytes that we had indexed those palettes. That's why. Okay. So it's not 16, it's just 5. Okay. Hey Vasterak, thanks for joining the stream. Sorry it's a little bit of a weird time here for compared to our usual streaming. All right, so let's check this again. See where we're at. closer. Oh, do I not have that breakpoint set anymore, or it's in the wrong place now? Let's see what the result is that we get when we're at that point. So sprite mem is EBAD. Let's have it. So it's actually off by 1 byte here because it should be 1300. Oh no, that is right. Okay, so 130. Yeah, so that's the right position. So now we're setting up the PPU for our write to the name table. It's interesting that this shows the shortcuts, but the source view, well, I guess it's because it's the source view. Anyway, so we're loading our X and then initializing all this stuff. Load a tile X. So now we're iterating over the screen, and Y should be 0. It is. So A should be the value 3, is what we said, right? That should be the value 1. So let me take a look at this here for a second. EBAD. EBAD. Oh, okay, so it's off by 1. Did I already increment it? I did. I already incremented it. Oh, right, because of, okay. So we only have to add 4. Alright, so now we're back to this, and sprite mem is EBAC, which should be the right thing. Let's see, where was the sprite mem load? It was here. A is 1, and then we shift it. And then we shift it some more. Yeah, that looks better. Okay, cool. So, all right, so that's looking good, because now the only thing that's wrong is where we're doing the attribute buffer stuff here. This is no longer correct because we are not handling that right now, because we're dealing with the rewrite of how this works for the backgrounds. So that would, I think, fix that. Whoa, that's cool. That's not what I wanted to do. I like it though. It's neat. That'd be cool to use intentionally if I knew what it was doing to break this. Oh, it looks like it's actually changing it every cycle or repeatedly. And so, yeah, because it's not, that's cool. So it's actually modifying the name table as the, as it's looping, as it's rendering. And so that's why it's getting that weird distorted view. That was cool. Let's see. So that's not what I wanted to do. Oh, because I'm not incrementing y at all anymore. Oops. Yeah, that would be a problem. We would put ourselves into an infinite loop here in the NMI, and that's no good. There we go. That looks like the map is now loading properly without the attributes, of course. Well, that's actually interesting. How is that possible that the map is loading properly? Because now the data is going the wrong way. Is that just a coincidence that it looked right? Oh yeah, okay. It is just a coincidence. Okay, so that's partly correct now. Now the issue is that we are traversing in the wrong direction. So what we need to do is, right now we've got row mem here and sprite mem and y. And let's see, I guess what we need to do is we need to subtract y from sprite mem so that we get our new starting, well, we need to subtract y and then another row. No, we just need to subtract sprite mem, y. So we want to transfer a to y, and then we want to store that in temp. And then we want to load a sprite mem. We want to set carry, and we want to subtract temp, and then we want to store that into row mem, and then we want to branch if carry is clear to done with row mem. And done with row mem. Other rows we want to take sprite mem, decrement sprite mem plus 1. And then we want to say load a row mem plus, no, sprite mem plus 1. And then we want to store that in row mem plus 1. So we're just transferring over these values here. And then we don't need to do this anymore. And then, so that's our new pointer into the map. Because instead of the way that we were dealing with the map before, where we were incrementing, where we had our map and then we were incrementing, we were going down the line. Now we just have, boom, map, big buffer of our screen, and we're loading the content of this part, and then we've got to rewind back. Oh, actually, you know what? No, that's stupid. We don't have to do that because we never changed sprite mem. We just used y to index into it. So we don't have to do any of that, actually. We just load a sprite mem, store a sprite row mem, load a sprite mem +1, store a sprite mem. I keep doing that, row mem +1. Okay, so these, let's see, mtop.y, all of this stuff makes sense to stay the same. The attribute memory stays the same. We're still in split mode. That doesn't change. The attribute index doesn't change. Okay, so that's good. And then the only other part that we have to change here is, instead of, I think we're incrementing row, adding to row mem, we actually want to subtract now. So what we want to do is we want to load it, we want to set the carry, we want to subtract that from row mem. Branch if carry is set. Yeah, and then decrement that. Actually, so then, did I do this wrong? This is okay. Loading, branch carry clear. Okay, that's fine. Sorry, I just, for some reason, I thought maybe I messed up the subtract by doing a branch carry clear instead of branch carry set. So if we do the subtraction and the carry is set, then we know that it didn't spill over into row mem 1. So now if it's clear we want to decrement row mem 1, we can still store this here. We can just actually call load new row. And then that, I think, will work. Let's see if that loads the map properly now. That's looking good to me. Turn off these breakpoints. Yeah, that's all looking pretty close to right to me. I don't think there's any issue. Let's see if we get our H properly. That wasn't 100% right. And I slow down the emulation here. Well, actually, I want to speed it up a little bit. I forgot I can fast forward and rewind here. So that last little like H shape is not right, so that makes me wonder if we have a problem elsewhere. We can go back and look at this and start counting meta tiles here, right? To draw the level map, I'm using tiled, which is just a standard tile tool, and then I'm using a tool that I wrote to convert it over to the NES, and the tool is C/C++ code, but tiled is a pretty standard tool, and then I'm exporting it out as JavaScript object notation, JSON. All right, so this is not exactly right. We're missing, let's see, I would guess we're probably taking every other line. Oh, right. Yeah, we are taking every other line because I'm subtracting 16 instead of 8. Because I forgot we're not writing the attribute bytes alternating in our map file. So let's restart this. So we should see 1, 2, 3, 4, 5, 6 metatile blocks there. 1, 2, 3, 4, 5, 6. Yeah. All right, cool. And then if we fast forward to the end, we should see if we... I thought we got to the end much quicker. We did, about half the time. Even with fast forward on, it seemed too quick. Okay, cool. So that's the end of the level there. All right, so now we're loading our metatiles properly. So that's good. That means that went surprisingly quick. It's got to be a record for this stream in 45 minutes. All right, so let's see. The next part I want to do is I want to see if I can get the metatiles normalized. So basically what I mean by that is, I explained it in the last stream, I'm pretty sure, but I'm not sure how clear I was with it. We may have a bunch of metatiles here, right? We have, you know, however many metatiles that we're actually storing for the entire game. And then what I want to do is I want to do for the map, I want to say, okay, we have these metatiles, however many there are. So let's say these are indices, you know, 6. Then we might say that we can even have more, but let's say for this map, maybe we only use 3 metatiles total. What I want to say is, okay, so index 1 is metatile 1, index 2 is metatile 4, index 3 is metatile 6. And the reason for that is that I want there to be a corresponding array of the palettes that it uses. So maybe metatile 1 uses palette 2, and metatile 4 uses palette 3, and this uses palette 1. And the idea there is that then I am not what's the word? I'm not storing the attribute values in anything other than the buffer that we have in memory for when the game is running, so that we don't have to store that separately in the map that we generate. And then we have completed what I wanted, which is that the metatiles are sort of distinct entities that we can look up. If we end up having support for more palettes, then we, I believe, should be able to use this structure to say, like, if this is metatile 7, then, you know, this might be palette number 6, and we should be able to have some sort of maybe a bit field or something that shows us which palette we have loaded. I'm not 100% sure what we would want to do for that. I'm okay with keeping it to 4 palettes right now. Hey, Midnight ST Suki. Hopefully I got that right. Maybe it's Midnight Suki. I don't know. Hard to know with people's aliases and handles and screen names how you pronounce them. All right, so memory limit on the NES is 2K. All right, so let's see. The CPU can address up to 64K in terms of the address range, but it only has 2K of RAM, and you can address additional RAM if it's stored on the cartridge. There's work SRAM, I believe it's called. Certain mappers have that capability and allow you to address the RAM, but we're not using that. I don't think we're going to need it. So let's see, how are we going to do this? So I think we're going to do the same thing that we did with the palettes, and it's not a super, it's not a super smart way to do. I mean, it's just kind of brute forcing where we're iterating over. What are we doing? We're iterating over the meta tiles, and we're looking up the meta tile in the palette lookup table that tells us which palette it's using. So let's see. So if the palette lookup table is equal to 0, right? So if we have no value in there, we're gonna store. Why did I do it this way? What was I going for here? Map palette equals map buffer p. Palette lookup table. Oh, okay, I remember why. So basically, I'm just kind of, yeah, like I said, it's brute forcing it. It's taking the index of the meta tile, and there can only be 256 of them, and it is saying, did we already put it into the map palette by looking to see if we set the value to 1 in this array? And then if we did, then we don't add it to the map palette. Otherwise, we add it to the map palette and increment the palette count, and then we're done. We just write the 4 map values. This doesn't take into account the fact that there may be more colors. It's just limiting. So I should probably put a note. This doesn't work if we need to support more than 4 palettes for the map, because it's brute force limiting to 4 palettes. And like I said before, this might be okay. We might be fine with a map that only uses 4, but at some point I'm wondering if we're going to have to potentially dynamically load palette values. All right, so how do we do this? How do we renormalize these values? I mean, basically we do the same thing, right? We create a lookup table or translation table of the meta tiles that we have in the map, except that we don't have to limit it in the same way. So actually, I want to rename this as, let's call this lookup table. Because that's really what it is. And then we can memset lookup table 0 size of lookup table. Let's do that after we're done dealing with the palettes. Okay, so let's normalize our map so that all the meta tiles are in an array from 1 to n. So again, this is kind of a brute force approach where we're just going to scan. We're going to scan the map. We're going to look for the meta tiles. We're going to see if they're already set up in the lookup table with a value of 1. If they are, we don't add it to the map. What are we going to call this? The meta tile index. We'll skip to the next one. Let me see here. So for int p equals 0, I guess we call it m for meta tile. m is less than map width times map height. I guess we should just store this off somewhere at this point since we're using it. Map total size is map width times just no point in recalculating this every time. And then let's see, so we have the lookup table and we say if lookup table map buffer p equals 0, then we're going to add it. And then we need a, I guess we, do we want to have, I don't know that I don't know that we want to establish any sort of limit on, I guess the most number of meta tiles you could have is 255, right? Because we're just storing 1 byte values, in which case so let's see, so worst case scenario, we're saying that we're re-indexing the meta tiles, even though, so that's like the trade-off, right? By doing this, we have to create a lookup table. We have to create this lookup table of mappings of the normalized meta tiles, and then if we have too many meta tiles, then it's actually less efficient because we're dealing with doing a lot of translation. And worst case scenario, if we used every meta tile in the map that we have, then we're doing an unnecessary lookup because we could have just kept it as it is. It's already technically normalized for that map. But let's see, the only other way I can think of that we could do what I wanted to with the palette lookup is, let me think about that. We have an array of palettes that we save. We know every meta tile has a palette that it uses. And that's what we're storing here. We're storing the index of the palette because, let's see, because why? Because I think we're brute force loading the palette range here. Let me think about this for a second. I think that's what we're doing. Yeah, we're brute force loading the palette. Okay, so actually we might need to do this in the next stream. I wanted to keep this one short. And I accomplished the bulk of what I wanted to do to get us going into this direction, which was I wanted us to change the way we're reading the meta tile information out of the map, and it didn't take that long. That wasn't too bad at all. But because we're brute force loading, or no, that's not the right way to, we've hard-coded the palettes we're loading, then this process is kind of broken, so we need to realistically, yeah, so we're not, I think we'll do this for next time. So basically the problem is right now we're not actually controlling the palettes that are being loaded. We're just loading palettes 1 through 4 and then saying, okay, we're gonna, we know that these are mapping to that in a really janky way, and that was just to get the map working. So what I want to do, I think, for next time is we'll update the asset tool to have the mapping of meta tile to palette index as a whole, and then we don't need to renormalize the map indexes. And what we would need to do is change the code that's loading. Where is it? So this code that's just looping through and loading these palettes. Wait, not this one. Load palette 4, store in PPU palette 0. Yeah. So the load palette call that we're doing in this palette loop is super janky because it's just all hard coded. So what we need to do is, realistically, what we need to do is we need to make a mapping of meta tile to palette index, and the palette index is an absolute index into the set of palettes that we need to be able to store. And then we don't need to renormalize our map data because the meta tiles can be looked up in that table of meta tile to palettes. And the only thing we then need to store is which palettes we need to load for real and not in this super jank way we're doing it right now. So I think that's what we'll do Monday. Like I said, I wanted to keep this one short. This is pretty short for me. It's only an hour basically. So if you guys have any questions, let me know, but I'm going to wrap it up here. As always, I'm posting these videos on YouTube. I am on Twitter at Clearvis. I am on Nintendo Age. I am normally streaming Monday and Thursday, 9 p.m. Eastern. Yeah, so Monday and Thursday, 9 p.m. Eastern is my normal stream, but I've got some things going on tomorrow, so I'm not going to be able to do that stream. I know it's Wednesday today, but yeah, it's it's sort of an off week, so we'll hopefully get back to our normal schedule next week. All right, so I will catch you next time. Thanks for watching, and thanks for everybody who subscribed on YouTube. That's pretty awesome. We're getting up there more than I thought we would get, and look for the Zero Page episode number 2 on number systems, and yeah, see you next time. Thanks for watching.